Good day and welcome. Today we are going to discuss the blood and its composition. At the end of this tutorial, you will have understood what the blood is and those substances that make up the blood. Also, we will look at the major composition of the blood that includes the plasma and the form elements. In addition, we'll look at those vital functions of the blood that makes it relevant to the survival of our body. Let's keep going on. So, what is the blood and what is it made of? To get a better understanding of this, we are going to refresh ourselves. Remember that the body is made of four basic types of tissue, which include the epithelial tissue, the connective tissue, the nervous tissue, and the muscular tissue. The blood that we are discussing is one of these types of tissue. So what is it? Can you guess it? The blood is a connective tissue. So by definition, the blood is defined as a circulating fluid connective tissue in the body. With that said, there is a field that is dedicated primarily to the study of the blood, taking into consideration the disease state and the normal state. This field is known as hematology, that is the study of the normal and disease states of the blood. With that said, now let us now look at some physical properties of the blood. We begin with the color of the blood. The blood appears scarlet for oxygen-rich state and it appears darker in an oxygen-poor state. So you will notice that the arterial blood will be scarlet and the venous blood will be darker because of its poor oxygen content. Also, the normal pH of the blood is 7.35 to 7.45. This signals that or tell us that the blood is somehow basic. And lastly, the volume of the blood is about 5 liters, which is approximately 7% of the other body's weight. So now let us look at the compositions of the blood. To obtain the blood or divide the blood into its various state, we use a machine known as the centrifuge. So what do we do first? We obtain a whole blood from our patient. That's the first thing. And the source of this blood is usually the venous blood. So we don't use the arterial blood because one, it is deeper, and based on access, the venous blood is much easier to access as compared to the arterial blood. We don't also use it too because the arterial blood is precious. It's already oxygenated and our body primarily needs oxygen. So a blood that has already received oxygen, taking it to our cells, we won't love to tamper with that. Rather, we go more for the venous blood. When this blood is obtained in a test tube, we have it placed in a centrifuge. Within a centrifuge, the blood is spun for a length of time, and the spinning of this blood causes it to divide into different layers. So the centrifuge blood here has an upper layer that is primarily fluid and is called the plasma, which constitutes about 55% of the whole blood. In the middle here is a buffer coat that is made of white blood cells and platelets, and this is approximately less than 1% of the whole blood. And lastly, we have the red blood cells located at the base, constitute about 45% of the whole blood. The red blood cells component of this entire whole blood is also referred to as the hematocrit. So the lighter two portion of our blood here is referred to as the form elements. So those are the various compositions of the blood. We'll now turn our attention to look at each of these states or each of these compositions, such as the plasma and the red blood cell, white blood cells, and platelets. Let's move on. We will begin our discussion of the composition of the blood looking at the plasma. The plasma is straw color liquid portion of the blood as we saw, and it is the most abundant portion. It constitutes about 55% of the whole blood volume, and that should be equal to 2.7 to 3 liters of the total adult blood volume that we saw, around 5 liters. With that, now let us look at the compositions of the plasma. The plasma is made of 95% water. So now we got a reason why primarily our blood is in a liquid state. So the plasma, which forms about 55% of our blood volume, has 95% water. The remaining percentage constitutes solute. And of the solute that are formed within the plasma, the plasma protein makes up about 7% of the total solute. And they are usually confined to the blood, meaning we are not going to find plasma proteins other area in the body as we do for other types of protein. Rather, these proteins are confined to the blood. Also, looking at the plasma protein, they are synthesized in the liver by hepatocytes, lymphocytes, platelets, and endothelial cells. So we have so many sources for the synthesis of our plasma protein in the liver. So what are these plasma proteins? They are the albumin that makes up 54%. Also the globulin makes up 38% and the fibrinogen makes up 7%. So let's now look at the functions of the different plasma protein. To better understand this, we are going to look at each of those plasma protein and take into consideration their importance in the blood. So let's get started. First, we'll look at the albumin. The albumin helps maintain the color osmotic pressure. So this entire big term color osmotic pressure just primarily refers to the pressure that is caused or brought about by the proteins that are formed within the blood. So this pressure helps regulate or control the accumulation of fluid in the interstitial space. So at the capillary level, there are blood that might be leaving the capillary to get into the interstitial space. The presence of this color osmotic pressure helps in regulating that. So that's why you see in cases of hypoproteinemia, where you have deficiency of albumin, there might be accumulation of fluid in the interstitial space, leading to a condition known as edema. Next, we'll look at the globulin. There are actually three types of this protein that are found within the blood. Two of these types, that is the alpha and the beta globulin, function in the transport of lipids and fat-soluble vitamins such as vitamin A, vitamin E, vitamin K, and so forth. The remaining one, which is the gamma globulin, actually function as antibodies in the immune system. So you've heard about the immunoglobulin. This is where most of these proteins form and they function in the regulation of the body's immunity. We turn our attention to fibrinogen. This actually it is an important clotting factor. Do you know about the clotting cascade? This refers to a series of reactions that usually goes on when you have a cut. So to prevent the leakage of blood, the body activates what is known as a clotting cascade. So a major component of one of those types of cascade is the fibrinogen. What happens is it gets converted into fibrin and the fibrin accumulate to prevent the loss of blood. With that done, let us look at other solutes that are present within the blood. So other solutes are nitrogenous waste, usually the urea, uric acid, creatine, and ammonia. Also, the blood is made of bilirubin that comes about by the breakdown of our RBCs and so forth. Next, the blood is also made of nutrients, vitamins, enzymes, hormones, and respiratory gases, the CO2 and the O2. In addition, we also have different electrolytes that are circulating in the blood. So the plasma content of the blood, as we can see, they are very important. They are numerous, but the major ones are what we've highlighted here. With the completion of our discussion on the plasma component or the fluid component of the blood, we'll now turn our attention to the form elements. What are these form elements? As we highlighted, you already remember some from our introductory slides. Those are the erythrocytes, also known as red blood cells or red blood corpuscles. We also have the leukocytes, known as red blood or white blood cells or white blood corpuscle, and we have the thrombocytes or the platelets. These are the form elements that are formed within the blood, and we are going to look at each of these form elements. We begin with the erythrocytes. The erythrocytes are also called the white blood cell, and to look at or better understand the erythrocyte, we are going to consider some important aspects of the white blood cell. Firstly, the erythrocyte is the most abundant type of cell in the blood. So, the account in male, the erythrocytes are about 5.2 million cells per millimeter cube, whereas in female there are about 4.6 million per millimeter cube. You'll notice there is a difference between the male concentration of white blood cell per millimeter cube and the female concentration. What is the reason for this difference? Remember the physiological state of the female, they have a monthly cycle that usually cause them to lose blood. So the loss of blood in that particular period also contribute to the reduction of their white blood cell. So for reason of such, we have the male percentage of the red blood cell being higher than the female percentage of red blood cell. Also, we will look at the functions of the blood. The blood primarily functions in the transport of oxygen and carbon dioxide. It takes oxygen from the lungs to the cells or tissues and it transports carbon dioxide from the tissue to the lung. The blood also contributes to the regulation of the acid-base balance by releasing CO2. You remember the bicarbonate reaction? So the more CO2 you have in the blood, it accumulates or it translates to the accumulation of more hydrogen ions. And more hydrogen ions will make the blood to be more acidic. So to compensate for this, those CO2 are transported to the lungs and they get extruded. So let's now look at the size of the blood cell. What is the average size of the white blood cell? So the diameter of the white blood cell ranges between 7.0 to 8.0 micrometer. And taking into consideration the thickness is actually between 1.7 to 2.4 micrometer. Let's get another thing about the shape. The white blood cell is biconcave, meaning there is depression on both sides of the cell, and it lacks nucleus and organelles. So to help us better foresee this, there is an image of the blood, and as you can see in the middle here, there is a concavity that render the white blood or the red blood cell biconcave. Also here, the diameter of the white blood cell, this cell is about 7.5 micrometer. And the one up here, we can see is about 2.0 micrometer. So these are some basic facts or figures about the red blood cell. Let's now continue to look at the compositions of the red blood cell. So that's component of the red blood cell. Firstly, the red blood cell is enclosed by a membrane, that is the plasma membrane, as other cells. The plasma membrane that surrounds the red blood cell is basically flexible. So it allows the red blood cells to change shape based on certain conditions they are exposed to. Like you found red blood cells traveling through capillaries, venues. I mean, those are very smaller vessels. So to allow the blood cell maneuver their way through the body, they have a very flexible plasma membrane that allows them to change shape. Also, the next major component of the red blood cell is the hemoglobin. And the hemoglobin constitutes about 97% of the entire blood, or the entire red blood cell, sorry. The hemoglobin, which is the most abundant component in the red blood cell, is made of four globin chain and four heme group. Of course, the heme group are formed by one protoporphyrin combined with an iron. For subsequent tutorial, we will go through the mechanism involved in the formation of the hemoglobin. But for now, just know that the hemoglobin is made of four globin chain bound to four heme group, and the heme group is formed by the combination of one protoporphyrin with an iron molecule. Also, the iron component of the heme bonds reversibly with oxygen. So, especially the divalent form of the iron molecule bonds with oxygen, and in the lungs, that's one point, and within the tissue, it releases the oxygen. So what happens is in the lungs, the hemoglobin affinity for oxygen is very high, and the affinity for CO2 is very low. So that's why we have the diffusion of O2 across the alveolar membrane in the lungs. Sorry, I'm getting bigger, but the transport of O2 across the alveolar membrane onto the blood cells and then CO2 being sent out. However, at the level of the tissue, the hemoglobin becomes more desirable of CO2, or it has a high affinity of CO2 and a lower affinity for O2. That's why O2 is easily released at the tissue level and CO2 is obtained in the red blood cell. Still looking at the components of the red blood cell, especially the hemoglobin, we would love to know what is the average concentration of hemoglobin in an adult. The hemoglobin is about 16 grams per deciliter in male and 14 grams per deciliter in female. Also, there are different types of hemoglobin. The hemoglobin in the adult is called adult hemoglobin, and the four globulin chain that form this hemoglobin are two alpha and two beta chains. In the fetal also there are four globin chains, and the hemoglobin there is called the fetal hemoglobin, and there are two alpha and two gamma chains. There is a low difference between the alpha or the adult hemoglobin and the fetal hemoglobin. The fetal hemoglobin has a higher affinity for oxygen as compared to the adult hemoglobin. That is why it is much easier for oxygen to travel from the mother through the placenta to the fetus. If they both had the same affinity for oxygen, of course, that won't be possible. Lastly, we have the sickle cell hemoglobin, which is usually exhibited in the disease state of sickle cell anemia, and the globin chains, there are also four. We have two alpha and two beta. However, in the beta chain, we have a mutation that occurs at the sixth position between valine and glutamate. So this usually causes the red blood cell to become a sickle shape when exposed to stress. Next, we will look at the formation of the red blood cell through a process known as hematopoiesis. Let's move on.